So yesterday we spent time and the day before finding the area of basic shapes, triangles, kites, etc. Now we're going to find regular polygons. Real quick, define regular polygon. So congruent sides and congruent angles. So a stop sign, the pentagon, etc. These are congruent. A home plate is not regular because it looks like the shape of a house rather than this. This would be a pentagon that's regular as opposed to a home base, which looks like a house. All right, so we've got a few pieces of vocabulary that we want to get through and identify, and it's all based around a circle that is what we call circumscribed about the polygon. So notice that each one of my vertices are on the circle, and everything is evenly spaced around. Question, comment? So first off, the radius of a circle is something like this from the center to any part of the circle. However, only certain parts of the polygon are touching the circle. So what we say for this is this: it goes from the center of the polygon to a vertex, to any vertex. So we call that the radius of the polygon. Next, I'm going to skip to side just to make it a little bit easier. Side here. And a side, of course, we already know what a side is. I don't want to spend too much time defining that. Side is there. Here's a new word for you, apothegm, and it does not mean a little creature that looks like a rat. An apothegm is rather it goes from the center to the midpoint of the side. From the center to the midpoint of the side. No apothegms are drawn yet, so let me show you where that would be. So from the center here to the midpoint there, and in a regular polygon, the apothegm will always be perpendicular to the side. So there is your apothegm. Perimeter is not too crazy. Perimeter, of course, is just distance around. And again, this is distance around the polygon. Distance around. Peri means about in Greek, and meter means measure. And finally, the central angle. The central angle is the angle formed by consecutive radii. Radii has two eyes, plural for radius. So a central angle would be, in this case, between the two blues there, or this is a central angle, this is a central angle, etc. Okay, there is a super secret formula that we will derive. How do we find the area of a regular polygon? Well, notice that what we end up doing is, if we were to break this up by drawing each radius, notice I have a triangle there, a triangle there, a triangle there, a triangle there, etc. So what can you say about all the triangles? Well, by side, angle, side, every single triangle is congruent. So really what we're doing is finding one triangle that many times. All right, so the area of each triangle is an area equals 1/2 base times height. But I'm going to substitute in relative, if I just look at this triangle right here, my height of the triangle is an A for apothegm, so let's use a small a there. And notice that my base is one of the sides. So I'll put S there for side. Now, so I can actually substitute in here to say 1/2 the apothegm times a side. Now, the number of triangles. The number of triangles. Well, we know however many triangles we have are, in this case, we have 5. But the number of triangles is just the number of sides. It's the same as the number of sides. So what is the area of my polygon so far? It's going to be it's going to be this triangle times the number of sides. Okay? So in this case, we'll just call it n for the number of sides. In this specific case, a pentagon, I have 5, but I'm just going to go generic in this case. So essentially, the area of the total is this right here, is A times S times N. Now, if you recall what perimeter means, perimeter is just the distance around. So perimeter is equal to the number of sides you have times each side length. So notice what you see. I see SN there and an NS there, or back and forth. So all I have to do is substitute in. So the area is going to be 1/2 of the apothem times the perimeter. Capital P, small a, and a capital A. Pay very close attention. Capital A there, lowercase there, capital there. All right, so here is our super secret formula for the area of a polygon. All we need is the apothem, and we need the perimeter to count those off. So let's practice real quick. Right here, if I am given the apothem length right there is approximately 14.5, and I'm given a side, which is 12, all I have to do is count it off. 1, 2, 3, 4, 5, 6, 7, and 8. So that means my perimeter is 8 times 12, which is 96. So my area is 1/2, capital A, capital P, or small a, capital P. And I'm going to substitute in the 96, and the 14.5. I am going to change this symbol to an approximate because of this apothem being an approximate. So we just plug that into our calculators, or simplify first to get 48, and then plug that in. Yes. Approximately 696. My calculator gives an exact answer, but the original was an approximate. Let me get the units in, centimeters squared. In this example, we're actually given the answer, sort of like Jeopardy. We know what the area is. We're trying to find the apothem. So I'm going to substitute in accordingly, but before I do that, I do want to find out what P is. So P is going to be equal to 12 times the 4.2. Where did the 12 come from? It's a 12-agon, or a dodecagon is how you say it. So I know what my perimeter should be. Since my original used equals, I'm going to use equals there as well to get 50.4. Like so. So starting with my formula, 1/2 AP, and substitute in 196 is approximately 1/2 A times 50.4. I can cut the 50.4 in half and then divide by that number, which is 25.2. So A is going to give me an approximate number, and I'll just write it up here, 7.82. Let's see if it says where to round it. It doesn't, so tenth is probably okay. I'll round out to the hundredths just for precision. And there we go. Let me put the unit centimeters. All right, in this next example, we're trying to find the perimeter of this shape. Sometimes they'll ask you to find the side, so just beware, pay very close attention. So I do have area is equal to 1/2 AP, so I'm going to substitute accordingly. Area is 130.8, so it's approximately equal to 1/2 times 6 times P. Together here, this gives me a 3, so when I divide 130.8 by 3, so P is approximately 43.6. Now, it doesn't ask me to go further. I'm done there. Notice centimeters there. But if it did ask me to find out what S was, what would I divide by? I would divide by 5 because it's a pentagon. So just for the sake of argument, let's go ahead and do that now to get 8.72-ish. 8.72-ish. Again, it didn't ask you to do that, but we will for an example. So in this next example, what we're going to do is we're going to find the area of the regular polygon, but what we're going to do is break this up into smaller, what we call reference triangles. Well, let's think about this real quick. If I were to draw one of the central, you can draw them all, but let me just draw two radii so I have a central angle. Okay? Well, notice that if I were to add up every single one of these central angles, all 6 of them, all the way around would be 360 degrees. Well, how many central angles do I have there? 6. So each angle is 60 degrees. Each angle is 60 degrees. So let me clean that up a little bit. Good, so now I can label this right here 60 degrees. Now just for clarity, I'm going to switch over to a separate triangle there. You don't have to, but I'm just going to do that for clarity here. So if I know that's 60 and I draw the apothem right here, effectively I've cut an equilateral triangle in half. And we already know what happens there because we've already seen this. This angle up here is 30 degrees. And this angle down here is 60 degrees. So notice we have a special right triangle. That this triangle right here, this big triangle, or excuse me, the small triangle, is a 30, 60, 90 triangle. So notice what we can do. If I can find the area of this, or I can use it to find the apothem or whatever, then I can multiply by that many triangles, or I can just find the area, excuse me, the apothem there, and then substitute it into 1/2 AP. However we would like. So if this guy here is a 12, because it says on the other side there, that means this one here has to be a 6. Now, if you recall 30, 60, 90 triangles, the radius is double that, so this one is also 12, but this one is going to be radical 6 times that. So that means my apothem is 6 radical 3. So the apothem is 6 radical 3. So I broke it up. I recognized I have a 30, 60, 90 triangle, and I was able to find the apothem with that. Now, of course, perimeter's not too crazy. It's just going to be 6 times my 12, so that's a 72. So now I can plug it into my formula, 1/2 AP. So 1/2 times 6 radical 3 times 72. Now there are a couple ways to write this answer. We can write it as an exact answer. So when I reduce here to get 36, so area is exactly 216 radical 3. And let me make sure my units are correct, inches squared. So sometimes it may ask you to write the exact answer or keep it in radical form. So it's 216 radical 3 inches squared. But if you multiply out, which I'll just multiply this real quick, we get 374.1 approximately. And let's see, it doesn't say how to leave the answer, so it's wise just to be bilingual with your approximate and your exact. All right, let's take a gander at this application. A soccer ball's outer covering is made by stitching together 12 regular pentagons and 20 regular hexagons. So I have pentagons and I have hexagons. I have how many of them? 20 of these and 12 of these. And I am going to add them together to get the total. So I find the area of one pentagon, multiply by 12. Find the area of one hexagon, multiply by 20, and we're going to add it all together. So we might need to draw this out, but we'll see. Both polygons have a side length of 3. And the pentagons have an apothem of 2.06. So to the nearest whole number, what is the total surface area of the ball? So if you find out that a sketch will help, go ahead and do that real quick. I'm going to draw a quick pentagon here with the given information. We're told that it has a side length of 3, and we're told that it has an apothem of 2.06, I believe. Yes. All right, so 2.06. So I know that each area of the pentagon is 1/2 AP. So 1/2 times 2.06. And the perimeter is going to be 5 times 3, so that's going to be a 15 there. Plug all that into my calculator to get an approximate value. I'm putting an approximate here, although they just tell me exactly, so for now I'll do exactly 15.45. But notice that I have to multiply this by 12 in order to find out what the area of all of those are. Next, for my hexagons, let me sketch that out. Offhand, we don't know the apothem, but we can calculate it real quick. If this is a 3, the side length, that means this has to be 1.5, which that has to be 1.5 radical 3. Why? Because it's a 30, 60, 90 triangle. So we do know the apothem and the perimeter now. So, again, 1/2 AP for this hexagon. The apothem is 1.5 times radical 3. And the perimeter is 18 because it's 6 times 3. Now I'm going to put approximately equal to after I plug all this into my calculator. So each hexagon is 23.38. So with your calculator, we are now going to take 20 of these. We're going to add it to 12 of the 15.45s to get our approximate value of the whole thing. Now it does say round to the nearest whole number. And in the end, we're going to change this to an approximately equal to sign. And it says round to the nearest whole number, so 653 and square centimeters. And there we go.